And what happened at the time, they pumped water from the river and refilled their reservoirs, which then went into the sprinkler systems. And they've had huge problems. They've got two guys working not quite full-time, but a big part of their job is repairing holes in the sprinkler system. And this is basically what he told me. The remainder of our buildings, manufacturing, warehouse, office covers an area of about 1.3 million square feet under roof. We have our own water supply, two reservoirs of 125,000 gallons and one of 500,000 gallons, both underground. We have an immediate problem with MIG in our building 7 that covers 440,000 square feet. There are 9 sprinkler systems in this building. We have looked at treating the entire water supply for our campus and at treatment systems at each individual system right during the building. We are currently replacing pipe as needed when pitted pipe starts to leak. This is a vicious cycle because we need to drain and fill the system, which provides new food and oxygen for the bacteria. Whoa, they got a problem. They got a huge problem. So of course I understood then why he was so anxious about his new sprinkler system in the Marvin Heritage Center, which is just recently built. In addition to that, they also they installed a chemical treatment system. Bill's going to talk about some of those things, so I'm not going to steal your thunder here. But I just wanted to mention to you guys again that after I got a number of phone calls and found that some of your gentlemen had issues at the hospital, possibly at Best Buy, some warehouses, of course you guys are here because you've heard of the issue, that maybe what we might want to do is in the fall that we bring together a panel of people behind the table, 4 or 5 guys, the fire marshal, maybe Bill again, maybe get a guy from Marvin, or maybe we can get the chemical person here and maybe have a shootout, 4 or 5 people here given the opportunity to ask questions. Yes?
When you do that, I'd offer a suggestion you do it as a joint meeting with AFE and get the facilities people here because they're the ones that are also going to benefit. They're the ones that are going to be seeing this problem first line before you guys in a lot of instances.
Exactly, and I think that's why, as I said, I have also other people calling me and saying that the problem is far bigger than the fire protection community has been willing to admit to this point, and that something needs to happen soon. So that's why I'm bringing that up. I'm thinking that, after we put this out, I got calls, and I got some very concerned people about this problem. So I just wanted to bring up what the issues were with Marvin Windows. That's only one customer. I'm sure we have other examples from maybe the Best Buy people, or we haven't talked to you yet, but that might be equally difficult to deal with. With that introduction, I think, Bill, why don't you tell us what you guys know about this and what you found out and what you're doing about this.
All right.
Thank you.
Thank you. Thank you for having me. And I want to thank you also going through the hassle of getting in touch with me and back and forth and emails and everything else too. When you all see that, how much I can back this up without running over me. Go ahead. A little bit about me, first of all, and the company. I've been in the business about 20 years. I started with Allied, and I was in their electrical division. And then through no want of my own, I left there and took about 5 years as a consultant. And then went with American Tube, and then they got bought out by Allied. So I went back to where I started. So Allied Tube and Conduit is one of the largest manufacturers of pipe and tube in the country, for those of you who don't know that. We have plants in Philadelphia, in Phoenix, and in Harvey, Illinois, which is our headquarters. As well as the sprinkler division, we have a mechanical division who manufactures pipe, and they do cut length type things. It goes into awnings and playground equipment and things like charcoal grills and automotive type parts and various things like that. We also have a fence division, which basically manufactures the fence framework for like chain link fences. Also, we manufacture the razor ribbon, which goes around the fences, on top of the fences for security purposes. And we have our electrical division, which manufactures conduit. So between those 4 divisions, we manufacture all that at all 3 plants. We're going to talk about, first of all, what NIC is, and from talking to some of the people here, I think they probably know more than I do on this. Some of the latest NFPA requirements, some insurance considerations, our ABF1, and then our new ABF2, and then some of the things that went into the warranty that we have on the pipe right now. The main thing we're going to be talking about, installation of bistatic coated pipe and the NFPA requirements as it pertains to MIC. What is MIC? Microbiologically influenced corrosion is a corrosion process influenced by microorganisms and is a major cause of tuberculation, pitting, and pipe failure in fire sprinkler systems, including carbon, steel, copper, and galvanized pipe. I have not seen any place where it has shown up or where it is affected in plastic pipe. But then again, plastic pipe has its own places where it can be used or not used. A lot of the bacteria that are involved in this, and I can't pronounce them all, but basically there are several different kinds that produce the red water, the odor problems, the slime, thick mucus, all the way down to finally the sulfuric acid, which they manufacture, and that's the thing that actually starts eating the holes in the pipe. Corrosion. Again, MIC is the process of bacteria, but basically you have to have, there's aerobic and anaerobic bacteria. One thrives on oxygen, one does not. You basically need both of these types of bacteria to actually cause the MIC. What happens is one of the bacteria will attach itself to the side of the pipe and start, it'll go around or attach itself to a piece of dirt or oil or something like that, attach itself to the pipe, and then the other bacteria will come along and basically feed off of the excrement of that other bacteria. So it feeds pretty much off of each other. Nice. You had mentioned how long this has been going on, and it's been in the wastewater treatment plants. You had mentioned the pulp and paper industry, places like that, for years. And what they essentially do in those places is just add a biocide type chemical and kill the bacteria, or if they have to, they'll just go in and replace the pipe as needed. This was a study by NFSA, and it's the first time that they started really delving into it. This was a study back in 1996. It's the first time they actually came out with any kind of trying to look at specifics of it. And what they tried to do here was pretty much show the time of detection in years, how long the system was in place, what kind of pipe it was, of course the location, and then any other incidental type things. You can see here was one that lasted 3/4 of a year, and that was on Schedule 5, that was in California. Here was one on steel pipe that lasted 2 years, Madison, Wisconsin. I'm not sure if there's one in Minneapolis on here or not. There's Minneapolis, 10 years, Schedule 10. So those are the time frames that any of this can happen. It's just all over the map. I just took 2 pages of this report. And by the way, now the report, at this time it was about 35 or 40 pages long. And this was 10 years ago. Now they basically have a book, and they go into much more detail and really trying to get down to, okay, why is this situation a little bit different than this situation? As far as the pipe, as far as the location, anything that has to do with it, we're trying to get more refined. Here's when we were talking about galvanized, 1 year galvanized pipe in Newark, New Jersey. 2 years, copper pipe. Anaheim, California. 0.65 years, Schedule 7, Texas. For whatever reason, I don't know why, but it seems like Texas and Arizona are just hotbeds for this permit. I don't know if it's because of the heat, humidity, whatever it might be, but we get calls and things from those two areas, Texas and Arizona, probably more than any other place in the country. NFPA 13, the latest edition, which is the 2002 edition, basically only came out last year. It takes that long to have any kind of revisions written up and approved and getting approved and all of that kind of thing. They are now working on the latest edition. They're supposedly going to have the final draft and all of the recommendations and everything finalized by the end of 2006. And it'll be called the 2007 NFPA 13. We're going to go now like the cars do, where they'll finish up making them in 2006, but they're going to call it the 2007 model. But these were some of the new things in the 2002. Owner's certificate. The owner of a building or structure where the sprinkler system is going to be installed shall provide the sprinkler system's installer with the following information. Okay. Intended use of the building. That was pretty much how it was done. A preliminary plan of the building or structure, how it's going to be used, and so forth. This was new in the 2002 edition. Any special knowledge of the water supply, including known environmental conditions that might be responsible for that. That was not in the NFPA 13 before this issue. Going a little farther, under 15.1.5, the water system supply. If they find out that there is a problem with the water, again, the owner shall notify the sprinkler system installer, and a plan shall be developed to treat the system using one of the following methods. This was new in the 2002 edition. Install a water pipe that will not be affected by the microbes. Two others, treat all water that enters the system using an approved biocide. Implement an approved plan for monitoring the interior conditions of the pipe at established time intervals and locations. Number two, I think everybody knows there's equipment available out there where you can put chemicals into a system. I don't see any problem with that. It's expensive. I think the units that Marvin probably used, I'm not sure, but I think it's probably around $4,000 or $5,000 for that unit alone, not to mention the cost of the chemical, once they find out what chemical is suitable for it. The other thing is Potter has some new pieces of equipment out called corrosion monitoring stations. You've maybe seen that. And that's basically, you can put those units in certain areas of a system, and it's just an easy access point where you can get at the water, basically to test it. So this is under the new NFPA guidelines. Basically, if you follow those guidelines, you have to do one of these things. Going a little further, just to show that there has been interest and things going on with this, NFPA 25 and 99 edition, they don't explain it or anything very much, but at least they do recognize that there is biological growth and MIC, and that these are some of the things you have to watch out for. Bill? Yes?
Do you want people to basically just butt into your presentation, or?
I don't care. Fine. Yeah, if you want to end, or you can ask questions as we go along, or anytime, later on. Insurance considerations, increased contractor premiums and exclusions regarding insurance company obligations. I don't have any insurance people here tonight, but I think if you even look at your homeowner's insurance, I bet anything that there's an exclusion on your homeowner's insurance that will not pay for any type of thing where it's mold, bacteria, anything that has to do with fungi or bacteria. I bet there's an exclusion on your homeowner's policy. There's a lot of policies in the contractor business and the sprinkler business, both on the contractor end or on the owner end. You know, the insurance companies just don't want to pay for this stuff. A good example would be a lot of the stuff in the hurricane areas. They're not going to pay for a lot of that damage. This one was back in 2001 ISO property. So these are just some things to think about. Okay, we came up with ABF, antibacterial formula. It's a coating proved to have superior resistance to microbial colonization of pipe walls, thereby delaying or possibly preventing the onset of neck when the system is first installed. We actually have had this product on for a little over 3 years now. We've got a 3-year track record with absolutely no failures caused by MIC. The product, of course, is shipped free to the customer. We have the coating on all of our pipe. Every piece of pipe that we manufacture, we have for the last 3 years, over 3 years. Every piece of our pipe up through 4 inch has it on. And of course, it complies with NFPA 13. One of the things that when they came out with the ABF1 initially, a couple of things. They didn't know for sure how long it was going to last. And that's why they didn't really promote it, advertise it, do a big spiel about it or anything else, because they wanted to do more testing on it and so forth. After doing that, they came up with ABF2, which now we've had out for, I want to say, 9 months, something like that. Advanced MIC protection, they now know it lasts longer. It's a much better coating. The old, first, it's not a biocide that's on there. Biocide is basically something like bleach. And a lot of areas, especially in sprinkler systems, that's one of the things that you don't want to have in there, is because, that's why you have your backflow preventers and everything else. If it would ever get into the potable water supply, and you have real problems. So it's not a biocide, and this was written up in the Pipeline and Gas Journal. I don't understand most of this, but the biggest thing is on the bottom here, it kind of mentions long chain acids increase the cross-linking and form a polymer-like complex across the metal surface. What we thought when we first came out with ABF1 was that it actually killed the bacteria, and that's not the case. What it does, it actually forms a coating, impervious coating on the interior of the pipe where the bacteria cannot attach themselves. The bacteria will only live between 8 and 24 hours. If they have nothing to attach to, they can't start their little feeding on each other type thing. So that's why they came up with the ABF2. Excellent resistance to long-term activity, no flash rusting. One of the problems we also had when we first came out with ABF1 was it goes on as a clear spray, but once it does that, the pipe itself starts to flash rust on the inside. And we'd have customers that would say, hey, the pipe is rusty on the inside. And we go, no, that's because of the coating. No. So they had to change that, and they did, and now they've got an additive. They have both a rust preventative included with it, and they've got a color effect to it, so it's great. Okay, some of the things that they did for material testing on the ABF2, they wanted to check again for the longevity and for the flushability of it. This was in a normal salt spray comparison, 24 hours side by side. This was with the old ABF1. And you can see it was actually starting to rust on the inside a little bit, 10 to 15%. With the new ABF2, there was no rust after the 24 hours. In the pipe industry, I don't care where you go, it's kind of the thing that they use as a salt spray test for basically anything that they do. So that's one of the initial things that they wanted to try to do. Then they took a bunch of pipe samples, both with the ABF2 and other pipe samples without it. They actually kept it in solutions of water and exposed it for up to 15 days in that water, and already the ones without a coating on started to have greater than 1,000 parts per million of bacteria on it, and the ABF2 didn't get any. The other things that they wanted to do was check. They thought, if the system is flushed, is that going to stay on there? The coating going to stay on? So they put it through a bunch of flush tests, and they actually got it up to 100 flushes. And the flush itself was 4 minutes of water flow, and then 1 minute rest, and then water flow, 1 minute rest, and repeated that for all the number of flushes were achieved. The flush itself was 63 to 65 gallons per minute, 65 psi, and the water was held at 68 to 80 degrees. Now that type of a flush is probably more than you would ever have in any kind of a flush situation in a sprinkler system, whether it's an inspector's drain or whether you actually flush a system. It will still probably be more than what you'd ever do. Okay, so they felt confident enough that they have now put a warranty on the pipe against nick. If you use it with all Tyco fire products, anything that the Tyco company makes, and we are a Tyco company, it's warranted for 5 years or 25 flushes. If you use other than Tyco products, it's still warranted for 3 years or 25 flushes. So it doesn't cost you any more because we put it on all of our pipe anyway. If you don't want to use Tyco products, you can still use the pipe and be guaranteed for 3 years. The requirements we have for the warranty is, yeah.
What about, what happens with the thread pipe?
Okay, I'll get into that with requirements here. Flush counter must be installed. Potter does manufacture a flush counter, both for wet and dry systems. And it's basically because of this that they started manufacturing it. There should also be an in-force inspection contract, which most of the time on new buildings, new installations, they usually have some type of maintenance agreement anyway. And it should be fabricated in accordance with the manufacturer's practices. It just goes into the flush counter. That is the top sheet of the spec sheet for the flush counter. That one is for the wet pipe system.
They basically use a modified flow switch?
That's basically what it is, yeah. And that's the one for the dry system. Recommended fabrication practices is threading to spray the interior ends. We do have canisters of the product available, both in swab cans and in spray cans. And again, that's the recommended practice that we have, outlet hose to be swabbed or sprayed. And that just goes into a little more detail on it. We get asked a lot of times about an actual specification, and I know a lot of engineers don't like to name actual products or anything. Basically, if they're following and all the provisions of NFPA 13, and as far as the pipe goes, you know, if they meet ASTM 135, 795, UL, FM approved, like most of them are and everything, there's no problem with it. Any questions? That's short and sweet. Yeah, Phil. Phil.
Say, in all your studies, did you find anything advantageous about galvanized pipe in reducing it?
Not really. Not really. We've seen just as many cases of galvanized pipe having neck problems, and in fact, several of them have been up in this area. I think Viking, I think they had one not too long ago. I think on a piece of 3-inch or something like that. I don't know what the job was or anything. But we've seen just about as much on galvanized pipe as we have on black pipe. Schedule 40, Same thing, I've seen it probably about as much on Schedule 40. Granted, I think the thinner wall pipes probably tend to maybe have the problem a little more sooner than like a Schedule 40. But one of the funny things about the MIP problem is you never know where it's gonna crop up. We had one case down in Texas where there were two exact same buildings, designed, built, everything the same, exactly the same, being fed by one main water feed. One building got MIP within 2.5 years, the other one didn't have it at all.
And are we basically talking about, we've got MIP, in other words, we started seeing corrosion, we started having system failure, we started having leakage in one building, but not in the other building. But was there actually, were the bacteria in both buildings? They just attacked in a different way?
It's just attacked in a different way. I think they found out after a while they did have the water tested, and it was the same water, and it was just a matter it did not affect the one building for whatever reason. So it's, you know, it's like a cancer. You don't really know. I mean, you've seen it. Getting back to the warranty type thing, as far as swabbing the hole and spraying the ends of the pipe and so forth. I probably shouldn't say this, but as far as the warranty is concerned, that's what you're supposed to do. Now, I don't know if you use the pipe and you want the warranty and you have a problem 3 years down the road or 4 years down the road, if they're really going to be able to tell whether the ends were threaded and the holes swabbed. I don't know. I don't know if they're going to be able to tell that or not. The other thing is, I've never seen a problem with MIC, and I've seen a lot of them. I've never seen a problem with MIC at the ends or at the head location. So it's always been mid-span, somewhere in between, you know, where it'll start leaking. I've never seen it done on a threaded area. So there again, I think they're trying to cover their tail on the whole thing by saying, you know, you should swab the holes and spray the ends. But you know, if something happens 4 or 5 years down the road, I don't know. I think eventually it's going to turn into be an attorney's either nightmare or dream, one or the other.
So what do you recommend for existing systems? You cut the section pipe out, or?
I guess that's pretty much up to, I would check. First of all, I think the first thing we recommend for anything is to have the water checked for sure. To see how bad it is, what kind of bacteria it could be, can it be helped with any type of chemical that would be suitable in a sprinkler system. After that, then it's pretty much up to the owner or whoever. You know, if it's only showing up in one area, and we've had that, where it was maybe, you know, you might have a big complex like this, and it only shows up on 3 or 4 of the ends of the branch lines, and haven't seen any more. Replace the 3 or 4 pieces of pipe there, and cross your fingers and go from there. You know, it depends on how far anybody wants to go with it, other than taking the whole system out and replacing another one. Marlin, they wanted to go with the adding the chemicals, so it'll be interesting if and how long or whatever that'll work for them, and whether the cost of putting that in justifies the means. But
And I would actually add to that, unbeknownst to Marvin or any of us involved in that project, most of the piping was allied pipe. It probably had the coating on it, but I don't think any of us was even aware that it had that coating on it, because you guys weren't advertising like that. It was not that long ago, I mean, last year.
I think was it last year?
Well, I mean, there was certainly no mention of any coating on the pipe. It was allied pipe, so you said coating
Well,
on it for years.
it could have been. Well, yeah, and
Right.
it should have been stenciled on the pipe.
It may have been, but it wasn't mentioned anywhere or came up in any conversations. But they basically added the chemical system, and their note was they hooked up the chemical system themselves, which was very easy to do. They bought the equipment and they installed it. It was about the short of it. And of course, it's only been a year, so nobody really knows at this point. And it was a pre-action system on top of that. part of it, so we don't know where that's going yet. But the question that I had was that list that you came up with from the NFSA, that you say, that basically did the study, what was their criteria of getting it on the list? Did it have to completely rust through? Did it rust through in one spot? And when you had a 6 months failure or a 7 months failure, what does that actually mean? Did it just simply start having a leak after 6 months somewhere in the system?
I can't really answer that for sure, but my best guess is that, and we kind of talked about that before, and I stopped at a customer this morning when we were talking about it, and he had one of his customers call yesterday, and they had a pinhole leak in a system that was put in like 4 years ago. And he said, what should we do? Well, he just went ahead and he replaced it. And I think that's what generally had been happening with a lot of the systems, years ago. They would have one leak, and okay, it was one leak, so they replaced that piece of pipe or cut out that section and went on from there. And now we're starting to see that happen where they'll have one leak, and 3-4 months down the road a little bit, they might have 1 or 2 more. And then now the knowledge is out there and everything that they're starting to get concerned about. Where before, I think it was just kind of, they just took it as an everyday occurrence almost. So.
Bill, you mentioned for the threading of the pipe, something about process of swabbing and spraying. Can you go into that a little more?
Basically, we just recommend that you use one of the canisters that we have, either a spray or the ones with the swab, and just make sure that that end where where it was threaded or where a hole was cut, that's coated with the product. And it is available, like I say, through our distributors. And for fabricators, we do a lot with fabricators. And when they first heard of this, they go, "Oh God, we're not going to go through all that crap," and which I understand, because it's going to take a little more time and effort to do it. But if there's a customer out there like a Marvin who's had the problem, they're the ones that are paying for it, and if they're going to pay the $4,000 or $5,000 for a machine to put chemicals in, they probably won't care about adding an extra little charge for taking a little extra care on the end. So as far as the warranty is concerned. But like I say, I think down the road, to be truthful, I think it's going to be an attorney's battle. It's whether they do swab it, whether they don't swab it, and they say it usually comes in the middle of a section of pipe anyway, so then it's a new situation anyway. So.
When you're talking about long-term building usage by Marvin and other large facilities who basically stay in the facility for a long time, what is the selling point to other commercial properties and clients who typically 3 to 5 years turn the ownership around to where you're trying to sell them a better product, and they don't care because they're saying, okay, you're only giving me 3 years or 5 years, I'm not going to build it, then it's not my problem. So as a person who specifies fire protection products and systems, what, in your opinion, would be my biggest selling point to my clients to utilize this product?
I guess the biggest thing that we're looking at right now is we're the only ones out there. It doesn't cost any more, so why not put in at least a certain measure of protection that's there. So it won't cost you any more or whatever.
That's the biggest point. It doesn't cost any more.
Now, I don't know if anybody else we had heard. I had seen something just recently that Bull Moose Tube has a similar type of a product out. I haven't seen it. I haven't heard anything about it. And theirs is a little bit, I think, different than ours. Ours basically was manufactured, and the manufacturing process of it and the way they came up with it was Dan Pope, who runs the Biotechnologies Incorporated, and that's the one where Marvin bought their chemical machine thing from. The Bull Moose Tube Company supposedly has a company called WHI, which manufactures their coating. We had originally gone with WHI, and I don't know the specifics, but for whatever reason, we broke away from them and went with Bioindustrial Technologies to get our coating. So there's something in the process that's a little bit different. I don't know just what it is. And I don't know if they really have it. Wheatland supposedly came out with a product about 6-8 months ago. I saw something on their website that they had it, and all of a sudden, just like that, it was gone, and I didn't hear anymore. So I don't know, either it didn't work, or they decided not to do it, or whatever.
Or typo button.
No, they were bought out by somebody, but not technically.
So is 5 years a magic number, or why 5 years, why not 6? Has there been any long-term studies on that, any aging studies that says that, oh boy, after 5 years, we got to back off of this one?
No, I don't think so. I think it's just a number they get, just like the 25 flushes, and you have to, how many times are you going to flush a building unless you go back into it, like a retail complex or something where you turn it off and completely add on to the building or something like that. 25 flushes should at least cover 25 years, but they could have gone to 100 flushes too, because they've actually tested it up to 100 flushes. So,
Is there a chance that if it comes out that this, after 10 years, the product with, the piping with your product still doesn't show any make that the warranties will slowly but surely be extended as the product proves itself?
possibly.
It's just that it's only been out there for 3 to 5 years. I think that's more the magic than, and it's the same when when we're talking about galvanizing or any other specification. I think it's basically the experience that a lot of people have had with certain piping that seems to last. Seems to be more than anybody actually proving it in the lab, I think.
I mean, you gentlemen, do you have issues? Have you seen this in your buildings?
Yes, sir. Franklin, Indiana facility. It's about 650,000 square foot building, it's 10 years old. And we had the flush Mick show up at 18, I think it is, systems, 18 risers. And 2 of them were really bad, had to be flushed and then the pipe replaced.
In a riser? How big was the riser?
They were 10 inch, maybe 8 inch.
Because that's kind of unusual too. We haven't seen too many cases where it's been in a larger size pipe. It's usually only been in smaller, like branch lines, maybe a cross line or something like that. But there's only one case that I know of, and it's in downtown Chicago, where there's a riser that's on one of the high-rise buildings down there, and the riser is 8 inch. And one contractor down there makes sure he keeps a bundle of 8 inch on hand all the time. Whenever it starts leaking, they go in and they shut it down and they replace it. So we can get it on 6 and 8 inch. Our Philadelphia plant has, because there's been some call for it out there, our Philadelphia plant has started to stock it. But there is an additional charge for that because that's a secondary operation. One of the things that make it good for us as a manufacturer to do it is we always had the equipment and the type of manufacturing process that we could do it directly in line. So that's why there's no extra cost or anything like that. Where with the 6 and 8 inch, that is a secondary operation, so that's why it does have an extra cost. We can't do it on galvanized.
Well, galvanized is not treated.
No.
What about the XL pipe?
We do XL, VLT, Dynethread, Schedule 40, 10, all the rest of our pipe up through 4 inch escalator. And we can't do it on galvanized mainly because when we send anything to be hot dip galvanized, it gets to the galvanizer and the first thing they do is put it into an acid bath to clean it off. So whatever's on there is going to be off anyway, and then they put the zinc over the top. We probably could do it again as a secondary operation, but I think the cost of that would be pretty high, especially in the smaller diameters. Yeah.
I got a question for this Mick. Is it proven it's just from water supplies?
I don't know if it's proven. That's the only thing that we've ever seen or heard that it's...
Well, you see trucks going down the road. It's raining, snowing, and you see stuff, you go out in the outskirt areas, pipe stored outside,
Mhm,
next to a cornfield with fertilizer.
mhm.
I mean, and you might have one or two pieces. Is it proven just in the water supplies?
I don't know if it's proven or not. I think
One
that's
of,
what it is.
one of the things we were told is that they're looking at possibly some of the cutting oils, the red oils
Yes,
could be a
Next
contributing
thing I said,
factor.
what about the cutting ones?
Mhm. I've heard of that possibility. Yeah.
No, I don't think they narrowed it down to the water supply.
Right.
I don't believe so.
Like say you see these fabrication outfits, if you do it, they don't cover the pipe, they don't cover it, it's going down the road, raining, snowing.
And it doesn't take much, you know, as long as there's some oxygen and some water there, which could be in there, or who knows how long it could.
With our facility, with the 18 zones, not all of the zones had it. A few of the zones had it real bad, some had some, and some had absolutely none.
Same water.
Yeah, same water.
And I've seen it on city water supplies and on well water and, river water or wherever, it's been all over. We had one not too long ago down in Kenosha, Wisconsin, where they had a leak, and that was in for 3 years, and it wasn't on a pipe, but it was in a bank, and it happened to start leaking right over the bank president's desk. And he really got upset about that. And then, of course, we found out and sent it to our Met lab, and they said, yep, it looks like it's Mick, you should have the water tested then. But then the city got all upset because our water is good, so what do you do?
When you've been looking at different systems now, have you really noticed that there's a difference in the system where the pipe comes from? Because as far as for flushing and testing, a dry system versus reaction and wet, and then even when you get into industrial or commercial uses where there's a lot more water flowing, I was wondering if any of those things seem to be a greater factor.
I don't think there's anything that's been greater than another. Personally, I think I've seen more on dry systems than on wet systems. And I think that's been basically a case of where there was water left in it after they tested it and everything. There was just enough water that it settled someplace or whatever, and the oxygen, it just started to grow much faster. As far as being in a manufacturing or an industrial or anything like that, that's just all over the map. And it's, we get probably in our Met lab, we'll probably get, I want to say 2 to 5 samples, or at least inquiries about Mick a week.
Bill, I know corrosion's a complicated issue, but have you talking to your R&D guys as far as what causes pinhole leaks? I know that, the mechanism of these sulfur-reducing bacteria form a tubercle, and underneath that there's kind of a microenvironment that drills a hole in it. Are you guys able to tell, if you look at a pinhole leak, what has caused it? Was it Mick or a different or more conventional form of corrosion?
They can't, really the best test is to test the water.
Okay.
I can look at a piece of pipe and it's got nodules and all this kind of thing, I can say, it looks like it's, to me, it looks like Mick, rather than just a general corrosion problem. But our Met lab, they'll take a piece of pipe and open it up and they'll check it and make sure that the steel composition and everything is correct so that there's nothing wrong with the steel. And then they'll be able to tell whether they think it is or is not Mick, but they won't say for sure until they actually would have the water tested. They can say, yeah, we think it is. You should have the water tested. Yeah.
Could there be any adverse effects on the pipe if you chlorinate it?
Chlorinate the water?
Or chlorinate the pipe?
Chlorinate the pipe.
Like you do with domestic water.
I don't know. That would be, well, we've had Mick problems with chlorinated water systems, so I don't know about chlorinated pipe, if that would really have a big difference or not either. So, I don't know. I think there's a lot to be learned there.
Do you have any environmental problems out in California with that?
That's not my territory, so I don't really know. We had one down in Texas not too long ago, not with coating, but it was on an addition to like a strip mall type thing. And they had a couple of pieces of pipe that had been in outside where they just hadn't run down, and it just happened to be an OSHA guy there who came around and he saw the brown water that was coming out of the pipe, so he thought right away, and he saw where it said ABF on the pipe, and shut him down, actually shut the contractor down for 2 days until he got confirmation that there wasn't anything wrong with it. But it was basically the brown water that we normally find in the sprinkler system. But as far as any problems with the...
You sent an MSDS sheet out with it then?
Sure. Yeah.
I think, Bill, it's about 8 o'clock. We can be available if anybody wanted to stay behind and ask a couple more questions on the meeting, basically. Okay, Bill's going to be around for a bit, so if anybody has any questions that they want to just ask Bill, go ahead. I would first of all like to thank Bill for coming out tonight and talking about a problem. I think what we've kind of done is maybe kind of open the door for a conversation, but it sounds like there's still a lot more to talk about in regards to making something that we definitely need to bring back and have more people from diverse experience to talk about this, because there seem to be a lot of questions still out there. I still have a lot of questions after this presentation as well. So thank you very much for coming here tonight and presenting this to us. I very much appreciate that. And thank you all very much for coming. And if you have any questions, Bill's still here for a bit. Thank you.
I think if I get more questions,